27. Division Part 2. We start with division with threes. This is the part of the multiplication table that you need to know to divide by 3. Right now, we're just dealing with stuff that's on the multiplication table. Long division is a thing for the future. Now we have 27 divided by 3. 3 times what equals to 27? 3 times 9 equals to 27. 27 divided by 3 equals to 9. 9 divided by 3? 3 times what equals to 9? 3 times 3 equals to 9. So 9 divided by 3 is 3. 15 divided by 3. 3 times something equals to 15. 3 times what equals to 15? 3 times 5 equals to 15. So 15 divided by 3 is 5. 24 divided by 3. 3 times what equals to 24? 3 times 8 equals to 24. 24 divided by 3 equals to 8. Now you may be thinking, is there a quicker way to do this? No, because you just need to remember your multiplication table. Not remembering your multiplication table is not an option if you want to have anything resembling success in, well, high school or even middle school. But then again, that depends on what programs you do in middle school. 18 divided by 3. 3 times what equals to 18? 3 times 6 equals to 18. 18 divided by 3 equals to 6. Again, guys, please remember your multiplication table. Please. For your own sake. 12 divided by 3. 3 times what equals to 12? 3 times 4 equals to 12. 12 divided by 3 equals to 4. 9 divided by 3. Again. So, 3 times 3 equals to 9. So 9 divided by 3 equals to 3. 21 divided by 3. 21 is 3 times 7. So 21 divided by 3 equals to 7. 3 divided by 3. Remember the properties of division. Anything divided by itself is 1. Oh yeah, there's also the pyramid, technically not a pyramid, triangle thingy that a lot of people use that I never figured out why they used. But here it is. And basically this means A divided by B equals to C, A divided by C equals to B, and B times C equals to A. That's the basic relationship. Now you may be wondering, how did I get that from this? Because A over B is also a way of saying A divided by B. Yeah, division's weird like that. Now moving on to division by 4. Now here's the 4 part of the times table or multiplication table, whatever you want to call it. And that's all that we need, at least for now. 20 divided by 4. 4 times what equals to 20? 4 times 5 equals to 20. 20 divided by 4 equals to 5. 4 divided by 4. The properties of division state that if something is divided by itself, then the quotient will be 1. Always. Unless it's 0 divided by 0. That's a little bit debatable. 32 divided by 4. 4 times what equals to 32? 4 times 8 equals to 32. 32 divided by 4 equals to 8. 12 divided by 4. 4 times what equals to 12? 4 times 3 equals to 12. 12 divided by 4 equals to 3. 28 divided by 4. 28 equals to 4 times what? 28 equals to 4 times 7. Therefore, 28 divided by 4 equals to 7. 36 divided by 4. 4 times 9 equals to 36. Therefore, 36 divided by 4 is equal to 9. 8 divided by 4. 4 times what equals to 8? 4 times 2 equals to 8. 8 divided by 4 is equal to 2. 24 divided by 4. 4 times what equals to 24? 4 times 6 equals to 24. 24 divided by 4 equals to 6. 16 divided by 4. 4 times what equals to 16? 4 times 4 equals to 16. 16 divided by 4 is 4. So yeah, basically general gist or general idea, if you don't know what general gist means, some people might pronounce it gist though. Anyhow, general idea, remember your multiplication table. If you want to take a break at any time during the video, feel free to do so. Take a break, drink some water, go to the bathroom, eat dinner, eat lunch, have a snack, do your practice problems, remember your multiplication table. Yeah, essentially, if you want to take a break, go ahead. If you don't want to take a break, or you just came back, hi! This is section 3, problem solving strategy. Make a table strategy. Which day had the most people present? Well, we don't really need to make a table anymore because it's right here. Although we could make a tally chart if we wanted to, but anyhow, step 1, understand. What do you know? Well, we know the day and the people that were there on that day. What do we need to find out? Which day had the most people? So step 2, we make a plan. We already have to use, well, we don't have to, but the purpose of this section is for you to learn the make a table strategy. Now we carry out our plan. Thing is, they already have a table. What we do need, though, is to organize how many people, well, tally more like, because the data is organized, but we didn't really tally it yet. Now, if you've never seen a tally chart, first of all, that's really weird. Second of all, I'm pretty sure a lot of people have seen a tally chart at this point, even if you're a little grade 3 child, but I'm pretty sure you've tallied things. At least I remember my teacher tallying things before I was in grade 3. Anyhow, so the first one is January 3rd, Jan 3, and then the second one is January 5th, Jan 5. Third one is January 10th. Okay, so on January 3rd we have Lorelai, 1, Daryl, 2, Jess, 3, Oscar, 4, Nina, 5, Ross, 6, Hazel, 7, Philip, 8, Karina, I did say her name right? 9, Tyson, 10, and Susanna, 11. Okay, now we count the people, well, tally the people, on February the 5th. Duncan, 1, Jess, 2, Karina, 3. Alan, 4. Penelope. Is it Penelope or Penelope? Because I've seen both. I've seen people say Penelope, and I've also seen Penelope. So, anyhow, Penelope's 5. Frank, 6. Lyra, 7. Madeline, 8. Greta, 9. Chara, 10. Norman, 11. Cole, 12. January 10th. Greta, 1. Philip, 2. Claire, 3. Jess, 4. Cole, 5. Jane, 6. Valerie, 7. So then we add the tallies up. 5, 10, 11, 5, 10, 12, and 5, 7. Which day had the most? There were more people on January. Okay, guys, is 11 bigger or is 12 bigger? 12. Is 12 bigger or is 7 bigger? 12. And that's January 5th. There were more people on January 5th than on any of the... Remember to make enough space for yourself. Other 2 days. Is the solution reasonable? I mean, it doesn't seem unreasonable. We counted our stuff correctly. What other strategy could we use to solve the problem? I mean, we could just completely abandon the chart and just count from the pre-given chart. Does your answer match the data given in the problem? It answers the problem, first of all. That's really important because I've seen answers that don't answer the problem. It's like those things where the teacher asks you, how many grapes did Alan eat? And then one kid raises their hand and goes like, he ran 80 miles. So yeah, you could probably see the problem there, but we answered the question. The question says which day had the most people present, not how many people on whichever day. So we didn't need to mention the number. We didn't mention the number, so that's fine. Does our data match up? Well, recheck the data. 3rd, 5th, 10th. Okay, 3rd, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 for January 3rd. 5th, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 for the 5th. And for the 10th, 1, 2, 3, 4, 5, 6, 7. We have 7. Our data matches up. Now we're going to do some practice problems where we have to use the make a table strategy. Chances are my tables right here are going to look very messy because I don't have a ruler, and tables always look better with rulers. Well, with the use of rulers in their creation. Jess is making a sign that says, be sure to join chess club. Which letter does she use the most? Okay, I remember the chess club at my high school being, they were an interesting bunch. Let's just leave it there. So what letters do we have? Well, we have B, E, S, U, R, T, O, J, I, N, C, H, L, and that's it. I'm going to use a capital L over there because, In case you haven't noticed, L kind of looks like a tally. Lowercase, at least. So let's tally. Well, B, 1, E, 1, S, 1, U, 1, R, 1. Oh, goodness, my tallies are starting to look like capital L's. Gasp, a tragedy. Save the tallies. E, 2, T, 1, O, 1, J, 1, O, 1, I, 1, N, 1, C, 1, H, 1, E, 3, S, 2, S, 3. Stop looking like L's. C, 2, L, 1, U, 2, U2, B, 2. Okay. So we have 2, 3, 3, 2, 1, 1, 2, 1, 1, 1, 2, 1, 1. I mean, the last time I checked, 3 was kind of bigger than 2, and 2 was kind of bigger than 1, which means that the letter that Jess uses the most, well, there's actually 2 of them, E and S. Jess uses E and S the most. Fun fact, did you know that E is the most commonly used, well, frequently used, the most used letter in the English language? Anyhow, 5 friends were in a tournament. Nadine came in 4th. Corey was 8th. Harry was 5th. Felicia was 6th. And Tony came in 7th. In what order did the friends finish? Well, we have 4, 5, 6, 7, 8, 1, 2, 3, but we don't know who 1, 2, 3 is. Anyhow, Nadine came in 4th. This is about as much of a table as this question will get. Corey is 8th. Harry was 5th. Felicia is 6th. Tony is 7th. Well, there's our order. Nadine, Harry, Felicia, Tony, and Corey. Great! Now it's time for the next section. We're back to division, and here we have divide by 6 and 7. Okay, so these are the parts of the multiplication table that's, well, 6 and 7. Divide. 35 divided by 7. 7 times what equals to 35? 7 times 5 equals to 35. Therefore, 35 divided by 7 is equal to 5. 12 divided by 6. 6 times what equals to 12? 6 times 2 equals to 12. 12 divided by 6 equals to 2. 54 divided by 6. 6 times what equals to 54? 6 times 9 equals to 54. 54 divided by 6 equals to 9. 14 divided by 7. 7 times what equals to 14? 7 times 2 equals to 14. 14 divided by 7 equals to 2. 28 divided by 7. 7 times what equals to 28? 7 times 4 equals to 28. 28 divided by 7 equals to 4. 18 divided by 6. 6 times what equals to 18? 6 times 3 equals to 18. 18 divided by 6 equals to 3. 36 divided by 6. What is 6 times 6? 36. So 36 divided by 6 is 6. 42 divided by 7. 7 times what equals to 42? 7 times 6 equals to 42. 42 divided by 7 equals to 6. 63 divided by 7. 7 times what equals to 63? 7 times 9 equals to 63. 63 divided by 7 is equal to 9. 42 divided by 6. Well, we got from over here that 7 times 6 equals to 42. And the commutative property says that, well, 6 times 7 is equal to 7 times 6. Which means that 42 divided by 6 is equal to 7. 24 divided by 6. 6 times what equals to 24? 6 times 4 equals to 24. 24 divided by 6 equals to 4. 49 divided by 7. It's one of these numbers. 49 divided by 7. 7 times 7 equals to 49. 49 divided by 7 equals to 7. Alright, time for some more division. We go into higher numbers such as 8 and 9. Find 40 divided by 8. 8 times 5 equals to 40. 40 divided by 8 equals to 5. This is the 8 part of the multiplication table that you have to remember if you still didn't remember it. Find 45 divided by 9. Well, okay guys, if it ends with 5 or 0 and it's not 0, if it ends with 5 or 0 and it's not 0, it's divisible by 5. 45 divided by 9. 9 times 5 is 45. 5. Of course, if it was 45 divided by 3, then it'd be different. I'm not saying that if it ends in 5 or 0, then it's always going to be, well, the quotient isn't always going to be 5. It's just that the quotient can be 5. Because in case you haven't noticed, if you divide, say, 36 by anything, you're not going to get a quotient of 5. Well, actually, no. You might. If, well, that thing wasn't a whole number. But we're talking about whole numbers here, so. Anyhow, this is the 9 part of the multiplication table. Divide. 27 divided by 9. 9 times what equals to 27? 9 times 3 equals to 27. 27 divided by 9 equals to 3. 64 divided by 8. Oh, it's one of these numbers. 8 times what equals to 64? 8 times 8 equals to 64. 64 divided by 8 equals to 8. 45 divided by 9. We already have that up there. 9 times 5 equals to 45. So 45 divided by 9 equals to 5. 16 divided by 8. 8 times what equals to 16? 8 times 2 equals to 16. 16 divided by 8 equals to 2. 72 divided by 9. 9 times what equals to 72? 9 times 8 equals to 72. 72 divided by 9 is equal to 8. 40 divided by 8. It's also already, well, done, but 8 times 5 equals to 40. So 40 divided by 8 equals to 5. Oh, 8855. Anyhow. Oh, there's some magic going on here. 36 divided by 9. 9 times 4 equals to 36. 36 divided by 9 equals to 4. 3, 2, 4. Okay. That's not that big of a pattern, so it's not that concerning. Cough, cough. 32 divided by 8. 8 times what equals to 32? 8 times 4 equals to 32. 32 divided by 8 equals to 4. 9 divided by 9. Division properties. Anything divided by itself is equal to 1, unless that thing is 0. Any non-zero number divided by itself is equal to 1. 56 divided by 8. 8 times what equals to 56? 8 times 7 equals to 56. 56 divided by 8 equals to 7. 81 divided by 9. 9 times what equals to 81? 9 times 9 equals to 81. 81 divided by 9 equals to 9. 48 divided by 8. 8 times what equals to 48? 8 times 6 equals to 48. 48 divided by 8 equals to 6. Well, we're going to move on to something else. More specifically, to unit cost. Unit cost is a cost for one item. How do we calculate unit cost? Well, say we have this question right here. Jamie wants to buy 1 slushie. The price for 6 slushies is $12. How much will it cost to buy only 1 slushie? Well, this is basically just division. Because think about it, if 6 slushies cost $12, then the cost of 1 slushie would be 12 in 6 groups, which is 12 divided by 6, which is 2. Because 6 times 2 equals to 12. It will cost $2 per slushie. Yes, guys, the slash is also another sign for per, like per as in P-E-R, which means something every something. Say 40 kilometers per hour, which means that you travel 40 kilometers in every hour. And if you don't know what kilometers are yet, well, pretty sure you've seen them somewhere on the street signs, though. Anyhow, find each unit cost. 6 chocolate bars for $18. Well, 18 divided by 6 is 6 times 3 equals to 18, so 18 divided by 6 is 3. That's $3 per chocolate bar. 4 notebooks for $8. 8 divided by 4 is, guys, come on, 2. So that's $2 per notebook. How do you check whether or not your unit cost is correct? Multiplication. Because if it's $3 for every chocolate bar, then 6 chocolate bars would be 6 times $3, which is $18. If it's $2 for every notebook, then 4 notebooks would be 4 times $2, which means $8. 8 tennis balls for $8. 8 divided by 8, division properties, is $1 per tennis ball. 1 times 8 is 8, so 3 binders for $6 per binder. Well, 6 divided by 3 is, 3 times 2 is 6, so 6 divided by 3 is 2. $2 per binder. If it's for 3 binders and it's $2 for every binder, then how much would you pay? You would pay $6, or 3 times $2. 9 badminton rackets. Yes, this is how you spell rackets, guys. I know, this is a Q, by the way. This is how you spell rackets. I find it super weird, but might just be a me thing. For $81. 81 divided by 9 is 9. 9 times 9 is 81. $9 per racket. If you think about it, then it would be, if it's $9 for every racket and I want to buy 9 rackets, then how much would I pay? Well, I would pay $9, which is 9 times 9. This is basically what unit cost is all about. Unit costs is, well, cost, which is money. Kate uses a $50 bill to buy 7 plushies. The plushies are $6 each. What is her change? So the unit cost is the plushies are $6 each. She wants to buy 7 plushies. Now what would the total cost be? 7, $6, which is 7 times 6. And that's $42. She uses a $50 bill. So she hands the cashier $50. The cashier has to give her back change, which is basically the amount that she paid extra. Now what's 50 minus 42? Well, 0 minus 2 doesn't work. Regroup. 10 minus 2, 8. 4 minus 4, 0. $8. So, Kate's change is $8. You should probably write the .00 just in case your teacher's picky. Macadamia nut cookies are $13 for a baker's dozen. If Simon wants to buy 5 of the cookies, how much will they cost? Here's the thing. A dozen is 12. A baker's dozen is not 12. It's 13. So if it's 13 cookies for $13, then division property, and you get that each cookie is $1. So if Simon wants to buy 5 of the cookies, then what's 5 times 1? 5. They will cost $5. Yay! Problem solving. Choose the best strategy. Howard is planning a birthday party with 17 guests. A pack of 6 party hats costs $4, and 1 cake can feed 9 people. The cake costs $10. Howard has 2 $20 bills. How much change will he get after paying for the hats and cakes? So what do we know? We know the costs of everything, and we know how many people that he has to supply for. What do we need to find? We need to find the amount of change that he will get after paying for the hats and cakes. Choose a strategy. Math. This is a math class, children. Math is meant to be done in math class. Now, okay, how many people are there? So there's 17 guests, but it's Howard's birthday party, so it's 18 people. 18 people, and there's packs of 6 party hats. Now 6 party hats, how many packs would that be? Well, 18 divided by 6 equals to 3, because 3 times 6 is equal to 18. So we have 3 packs, and each of those packs costs $4. What would that be in total? Well, 4 times 3. 4 times 3 is the cost for the hats, and the cost for the hats is, well, $12, because that's what 4 times 3 is, at least in dollars. Now the next thing that we need to, take care of is the cakes. So each cake costs $10, and 1 cake can feed 9 people. There's 18 people. So the amount of cakes we need is 18 divided by 9, which is 2. And the amount that would cost is $10 times 2, which is $20. So $12 plus $20 is the total cost of our hats and cakes, and that's $32. The change depends on how much he paid in the first place. And it says that he has 2 $20 bills. 2 $20 bills is $40. So he paid $40, and the change would be 40 minus $32, which is $8. Howard will get $8 of change. Or Howard's change is $8. So let's check. Look back at our answer. Does it make sense? Well, it does make sense. We could use division to check, or just work backwards in general. But first, let's reread the question to make sure that we get our information correct. Howard is planning a birthday party with 17 guests. 17 guests plus host is 18 people. Pack of 6 party hats costs $4. And 18 divided by 6 is 3, which means 3 packs. $4 each, that's 12. 1 cake can feed 9 people. 18 divided by 2 is 9, which means 18 divided by 9 is 2, because that's how it works. So the cost of the cakes is, the cake costs $10. That's $10 times 2, because we need 2 cakes. And that's $20. 12 plus 20 is equal to $32. And 40 minus 32 is indeed equal to 8. So yeah, we're right. Moving on to some, well, less problem-solving-y stuff. Some algebra. Expressions and equations. Expressions are, well, number sentences, or a number sentence, that contains numbers, at least one operation symbol, and sometimes variables. An equation is just a mathematical sentence that contains an equal sign. Is 2 plus 3 an expression? Yes, because it has numbers and it has one operation symbol. And that operation is addition. It doesn't have to be, well, an expression with variables, but it's still an expression, since it says sometimes variables. So yes. Is equal 5 an expression? No, because there's no operation. No. No operation. The equal sign is not an operation, guys. Is 2 plus 3 equals to 5 an equation? Well, there's an equal sign, and there's numbers and an operation, so that's usually what a mathematical sentence is called. Well, it contains. So yes, it is an equation because it's a mathematical sentence, numbers and operations, and it has an equal sign. Practice problem time. Corey has 4 packs of slime. Abigail has 2 packs of slime. Jenna has double the amount of slime as Corey and Abigail together. So Corey and Abigail together is 4 plus 2. Double the amount as Corey and Abigail together would be 4 plus 2 in brackets times 2, because the order of operations states that we have to do the stuff in the brackets first. Now one of these is an expression. Well, both of these are expressions at the moment. So let's add an equal sign to one of them to make one of them an equation. Now what is this equal to? Well, it's equal to Jenna, but it's also equal to, brackets first, 4 plus 2. 4 plus 2 is 6. 2 times 6. 2 times 6 is 12. There! Now, choose one of the symbols. Plus, minus, multiply, times, whatever you call it, or divide to make the equation true. Making an equation true is another way to say, well, making both sides equal. So we have 7 minus 5 equals to 1 and 1. Now what is 7 minus 5? 7 minus 5 is 2. Now 1, 1. How could we change that into 2? We can't do subtraction or division or multiplication because that's 0, 1, and 1. But 1 plus 1 equals to 2. Yay! We're done with that. 6 something 4 equals to 8 times 3. What is 8 times 3? 24. 6 what 4 equals to 24. 6 times 4 equals to 24. 14 something 10 equals to 24. 24 is, well, 14 plus 10. So, yay. 36 something 4 equals to 9. Now last time I checked, 36 divided by 4 equals to 9. Okay, one thing that's bugging me right now, this is actually a symbol in math, and it's not the addition symbol. So yeah, this is bothering me, but hey, it's a fill in the blank. I'm gonna let it go. Anyhow, moving on to the next section. Now this is something that you do in science a lot. Translating words to expressions. Stephanie ate out 4 times this month. Lori ate out 3 more times than Stephanie. Write the amount of times Lori ate out as an expression. So Stephanie ate out 4 times, and Lori ate out 3 more times, which means that it's addition. This is the expression. Find the keywords that will tell you what operation to use. The keyword is more. You could also write the expression as S for Stephanie plus 3 if you want a variable. But that's the general gist of it. Write each phrase as an expression, then solve. 8 less than 32. The moment you hear the words or see the words less than, it's subtraction. 8 less than 32. That's 32 minus 8. Why not 8 minus 32? Well, if you think about it, there's 8 less candies than yesterday. There were 16 candies yesterday. That's 16 minus 8. 81 together with 33. Together is for addition. Now let's solve these. 32 minus 8 is 24. 81 plus 33 is 1 plus 3, 4, 8 plus 3, 11, regroup, nothing to regroup to, 114. 72 divided by 8. It literally says divided right there. So that's division. 72 divided by 8. And that is 9. The difference between 73 and 156. Remember what I said before about subtraction? It's to find the difference. This is subtraction. And because you guys haven't really done negative numbers yet, it's 153 minus 73. 6 minus 3, 3. 5 minus 7 doesn't work, regroup. 15 minus 7, 8. 1 had 1 regrouped out of it, so now it's 0, so now it doesn't count. So that's just 83. The product of 7 and 8. Now remember, quotient is for division, product is for multiplication, difference is for subtraction, sum is for addition. Now that I just said that product was for multiplication, what do you think, well, is the operation over here? Multiplication. 7 times 8 equals to 56. 53 minus 18. It says minus right there. And that's 3 minus 8 doesn't really work. Regroup. 13 minus 8. 5. 5 got 1 regrouped out of it. Now it's 4. 4 minus 1. 3. 35. 6 times 6. It says times. Times is multiplication. 6 times 6 is 36. Remember your multiplication tables, kids. 7, 3, and 9 items in all. In all is together. So that's addition. 7 plus 3 plus 9, and that's 10 plus 9, which is 19. Write an equation for the situation, then solve. Molly exercised for 45 minutes every day for the week. So there's 7 days in a week, 45 minutes every day for 7 days. John only exercised on weekdays, but does so for 1 hour every weekday. That's 5 hours. Because there's 5 weekdays, and 5 times 1 is 5. Who exercises more? Now I know that you haven't really gone through double-digit multiplication yet. Here's a sneak peek though. If you're doing more than 2 digits, well, more than 1 digit actually, it's better to do it with vertical form unless you actually know and can do it in your head. That's a different matter. And this is more than 5 hours. So the equations would be 45 times 7 equals to Molly, and 1 times 5 equals to John. Technically, it's not 1 times 5, because this is minutes, min, and this is hours, HR. Yes, guys, these are the short forms. It's technically 60, because 1 hour is 60 minutes. We still end up with Molly exercises more. Because 60 times 5 is 300, and 45 times 7 is 315. Molly exercises more. Done! That's it for this chapter. Remember your multiplication tables, and see you next chapter.